Bon, ben, commençons ça. Donc, bonjour tout le monde. C'est un grand plaisir de vous souhaiter la bienvenue à notre première édition de notre série webinaire En Lumière qui va présenter l'expertise des membres de la communauté de l'optique photonique. Et aujourd'hui, on a la grande chance d'en apprendre davantage sur l'expertise au CNRC dans les technologies Lidar. Nous allons notamment avoir le droit à une présentation de leurs installations, leurs activités, puis les plus récents développements dans ce domaine-là qui est en pleine croissance, qui est vraiment excitant. Puis pour nous en parler, on va d'abord avoir Chris Canters, que vous voyez, qui est à la direction de la commercialisation et de la propriété intellectuelle au CNRC, qui va être suivi de Michael Davison, qui est au développement des affaires dans le groupe d'électronique et de photonique avancée. La présentation aujourd'hui va avoir lieu en anglais, mais sachez que vos questions sont les bienvenues en français également. Et d'ailleurs, je vous encourage fortement à utiliser la section Q&A dans le bas de votre interface pour poser vos questions qui vont pouvoir être répondues à la fin du webinaire. D'ailleurs, vous pouvez les poser à n'importe quel moment, ça va vous faire plaisir. Alors, sans plus attendre, I will let Chris present what NRC has in store for us today. So, Chris, the floor is yours.
Merci, Jean-Christophe, and certainly on behalf of Mike and Patrick and I want to thank you and Madison and the team at Optonique for putting on this event. And what looks like we've got a pretty good audience for it as well, which is fantastic. It's certainly a pleasure for us to come and talk to you today about some of the exciting technology development work that's going on at NRC that has relevance to the LiDAR space. I want to start off by saying that we're not LiDAR experts. We're hoping that a lot of you in the audience are LiDAR experts and that we can at some point connect following this kind of talk and put our brains together in order to help get some of these technologies through to the marketplace. That said, obviously the AEP group, of which Mike and Patrick are part of, definitely has done a lot of work in producing leading edge materials and devices, a lot of it for the communication sector, and has worked quite a bit with companies in that space in order to bring those things all the way through the development cycle and into commercial reality. And we're hoping in the LiDAR space we can do something of a similar nature going forward. Just to give you a little context, over the last couple of months, we put together a small team and we did a lot of kind of a deep dive into the market side of the LiDAR space, the supply chain, etc. And we're looking for technology gaps, and then we did a deep dive into our own R&D projects in AEP and came up with a list of technologies we think could have a real place in filling some of those technology gaps in the LiDAR space. So Mike's going to go through some of these technologies, and you'll see they're kind of grouped into three main areas: the light emitters, which is the lasers. Then we're going to talk about the beam steering, which is optical phase arrays. And then it's going to be finished off when we talk about the high sensitivity silicon-based flash LiDAR sensors. And I want to also start off by saying that the TRL level of the technology varies dramatically, as you might expect. NRC in some cases can take technology to a very high TRL level, and in other cases we just don't have the expertise, and that's why we rely a lot on these kind of research collaborations in order to achieve that. So today, with the help of Optonique here, by hosting this event, we're hoping to give you a good high-level look at our capabilities, facilities, the technology that we have that we think could be quite relevant to the LiDAR space. And we're hoping actually that the real thing that comes out of this is follow-up one-on-one discussions with each of you to talk about how we might collaborate in order to take more of the technology, either technology of your own or technology that we have or we're talking about here today, and bring it through and bring it through the process to get it to commercialization and new products from Canadian companies. So next slide, please. So very high level overview on NRC. We're about 5,300 people, 1.1 billion in annual expenditure. A lot of companies out there know us more from the other piece of our business, which is NRC IRAP, which does a lot of support work for small, medium enterprises. Mike and Patrick and I are on the other side of our organization, which is the research side. And you'll see here, we've got facilities and people kind of spread all over the country. But we're going to focus, Mike's going to talk about some of the AEP facilities in particular, which hopefully is of interest to this audience. A couple of things I just want to mention here as well. We have a long history of working with companies to develop technology. And you can see there that last year we had over 1,000 client engagements in that spirit. The other thing I want to mention, it's a little plug for Explore IP. For those of you who are not aware, ISED has put together a website which allows you to search all of the public IP that's available for licensing. So you just go into your Google browser and type in Explore IP, and you'll be able to see, and it's not just IP from NRC, it also is from all the universities in Canada, etc. So for those of you who are looking to maybe leapfrog by, building on development work that's gone on already, you might want to take a peek at that. Next slide, please. So we won't talk about all 14 NRC divisions at our research centers within NRC. We're going to highlight the advanced electronics and photonics because it has a lot of relevance to the Lidar segment and the technologies that we've developed there. But we did want to highlight two other areas going forward. One is aerospace, and the other is automotive, surface, and transportation. And the reason we want to highlight these is, essentially they have a lot of expertise in testing capabilities for these end-use markets. So if you have your own technology that you may want to test in under certain circumstances or what have you in those end-user markets, we can put you in contact with people there. Or in this particular case, we also have strong connections in order to try to advance some of these technologies to higher TRL by tapping into that expertise. And a good example on the automotive and surface transportation side right now, they are working with Lidar systems, looking primarily at things like how does snow, fog, etc. Cause issues for them, and how you can use software to mitigate those kind of issues. So again, two other areas that if you're in this space, two other parts of NRC that might be quite relevant to you. And I think with that, I will pass the baton over to Mike, and he'll get into the meat and potatoes here of our discussion.
All right, can everyone hear me? I'll assume that the answer is yes. My name is Mike Davison. I'm business development within the Advanced Electronics and Photonics group. Although I like to enjoy a beer in French, if I were to do this, ça fait depuis une quinzaine d'années que je parle en technique en français, and it would take me all afternoon to get through this deck. The good news is, I think it's less than 10 slides. So I'm going to pile through a bunch of this just to make sure that we can get down to some of the relevant things more quickly. I joined the NRC about 9 years ago into this group. Foundationally, this research center is staffed with about 170 professionals, most of them on the scientist and engineering side of the equation. We do have some manufacturing capabilities, so we have technicians and operations and admin support around that as well. The core history of this group has been focused on developing novel materials and devices, most specifically for the communications industries. Canada had a real strong commercial network of companies that grew out of old BNR research days. And what was realized was that we could play at the NRC a fundamental role in de-risking long-term future tech and next generation technologies, so that we could bring that know-how to help de-risk product development for the industry. As such, we built a facility and a team here in Ottawa, and our expertise span all the way from design and modeling of novel materials, all the way through fabrication, testing, and even prototyping for manufacturability. Although we have all of these capabilities and expertise in-house, there's only a few areas where we can scale up into offsetting and assisting bringing technology to market. But we need all of these capabilities in order to help develop and de-risk new products. So specifically in Ottawa, we actually run 2 compound semiconductor fabs. The small circle in blue out at the Montreal, on the image on the bottom, is of our advanced technology fab. It's a smaller fab, and it is meant for very low TRL exploration of novel materials and devices. We work with pieces of wafers. We do work with wafers, and it is the real sandbox for where cutting edge research begins. Further down the hall, in the big red circle, is what we refer to as the CPFC, the Canadian Photonics Fabrication Center. And it's a commercial foundry, semiconductor fab. It's where we operate in the 3-5 world. And structurally, we operate under a pure play foundry model. And what this means is we do not make parts, and we don't even have a PDK or an SDK. We work with client designs, client products. They bring their own IP with them in this space. And we either help model and design new devices based on their needs, or we just figure out how to make their devices better, higher performance, higher manufacturability, better yields. These are the types of things that happen within the CPFC. It's really the commercialization, productization arm of the equation. And this is really what makes us unique, is having these 2 different facilities working collaboratively within the same processes and equipment type scenarios, in that it's one thing to academically bring an idea to reality, but it's another to be able to commercialize it. And if you don't have the yields and you don't have the performance in volume, you don't have a product. And this model of our 2 fabs working together in a pure play type model is very unique globally. I will reiterate that we really don't have very much expertise at the system level, and we have some expertise at the component level, depending on your application. Truly, that's what our customers are, and that's what they do. What we are the materials and device exploration, and then the manufacturability of process. And we keep that IP to ourselves. Our process, our materials, how we do things, that's the IP that we keep. And client IP is background IP, what you're trying to do, how you're going to do it, that belongs to you. In some cases, we embark on collaborative IP development, where we can sit around a whiteboard and say, here's what we bring to the table in terms of materials or processes. What do you bring to the table? And what happens if we get together? Could we do something new? And in fact, I'll even speak to one of those massive wins that we've had with a great client of ours in another slide or 2 in that light. All right, so what is it that we bring to the table for Lidar? Well, we haven't developed anything specific for Lidar. We have a toolbox of technologies that come out of a lot of the research in the communications space over the years. And it just so happens that some of them may be very appropriate for solving some of the performance gaps that Lidar faces. Lidar systems, seeing the world 3-dimensionally in real time, is a game changer in terms of application spaces. And in some spaces, our technologies may be appropriate for certain aspects of LiDAR, and in others they won't be. But certainly, when we talk about moving parts and we talk about sensing, multispectral sensing, there are various technologies that can solve some of these issues that the industry is facing. And with that, let's talk about specifics. All right, so I just mentioned, we'll start with the lasers and the emitters side of things. And I just mentioned a big win that collaboratively, we've embarked upon with a partner of ours. And this partner has a lot of experience developing custom lasers for all sorts of different industrial applications, and even came from the communications space once upon a time. And they came to us and said, we are really good at developing way down the performance map for niche applications that really want laser type performances, but industries haven't figured out how to get there yet. And so they brought an absolute design and system expertise and how to test and what does this device have to look like when it's actually in performance mode. And we brought a breadth of novel ideas on how to structure and design a laser cavity that would lean in those directions. And we've spent the last couple of years refining those models, refining those designs, and they are currently bringing these products into commercial viability with us right now. You'll have seen these types of presentations at the big shows over the last, from Photonics West all the way through to the more commercial shows. And being able to bring this level of performance for extremely low noise signals at 1550 wavelength is the path forward for FMCW architectures, looking for onboard automotive type LiDAR systems. Yes, we understand, and we've seen all the presentations, that it's still the Wild West, and there are different architectures, being FMCW versus flash versus 905 and 1300 nanometers. But if you can bring a system level low cost version at a 1550 wavelength, being eye safe and higher power capable, you really have a best in class solution. And this partner of ours has been able to do that, and they are demonstrating it, and they are bringing it through to commercial reality with our help in terms of not only proving that the tech works, but bring it into a commercial viable manufacturable kind of space. Okay, so that's a scenario of an absolute win where we brought the best of both organizations together to do something together collaboratively. The next three slides, the first one is still in the laser space, are areas that we have not brought existing technology into the LiDAR space, or even really into this type of an application. But we've already seen proof points that it should be a game changer for the right partner that's going to operate in that area. And the first one is quantum dot lasers. For those of you who haven't spent a lot of time looking at quantum dot laser cavities, basically it's a laser chip cavity that emits multiple frequencies at the same time. There's been a lot of research over the last 20 years academically, and there have been varying amounts of success at different wavelengths. I can say that intrinsically, our group has been at the forefront of this type of research, and we are one of only 2 places in the world that has really figured out how to commercialize it, make it manufacturable at 1550. And we've done it well enough that it's actually, we've got partners making commercial products for the datacom center space. And they've been deploying into data centers and making laser systems, communication systems based on a 4-channel variant of our quantum dot lasers. And what gets very interesting about this technology is that we can manipulate how many frequencies get emitted. Okay, so the On the screen in the upper quadrant, there are 3 cells. And what we can do is we can choose, basically by varying how we do the grading structure on the laser, where we want wavelength peaks to happen and where we don't. And this will spread the amount of power coming out of the entire cavity across X number or N number of channels that you choose. And so the other neat aspect of quantum dot lasers is that they are natively extremely low noise, very steep angles, and so sidewalls. And so the image in the middle of the screen is just a typical snapshot of the difference between a quantum well-based laser and a quantum dot-based laser. So the name of the game for Lidar, obviously, is the sensitivity. How far you can reach with and still see a clean signal with as limited power budget as possible dictates how far you can see in the world, how quickly you can see in the world, and where you fit in terms of regulations and safety. Down in the bottom right, the reason that I brought this idea into the presentation today has recently there's been a publication in Nature, the Nature magazine for scientific reports specifically on this topic, and the publication was for a LiDAR application, and they are taking 1550 based coherent quantum dot comb lasers and running them at broader spectrum. And the architecture they've chosen is based on having a myriad of optical amplifiers to pull up the signal power in specific groups of the channels emitted. And so it's real, and this architecture should be very interesting. And our ability to commercialize and manufacture quantum dots at 1550 is extremely sought after. Our biggest problem at this point is we have too many industries and too many partners interested in what they can do with quantum dot lasers. And so outside of the datacom world, where it's all about reducing how much power you can get into the data center, this type of approach is also the leading edge of terahertz computing. And so if you want a terabit computer, laser source, this is how you get there. And so we're setting benchmark breakthroughs. It seems like every quarter there's a new benchmark that's been broken by taking this approach. All right, I'll move on to the next one. Anyway, fairly low TRL in terms of commercialization, but we've been building and making quantum dot lasers in-house for the better part of the last dozen years. All right, let's get farther down into the lower TRL space. And moving parts in LiDAR are always going to be a problem, especially as the industry moves towards automotive and lower cost and harsh environment at lower cost scenarios. And getting away from moving parts into solid state is one of the holy grails of that architecture. The catch is going to be how much power do you need and how far can you steer a beam from a solid state device. Our group on the silicon photonics side of the house, this is no longer in 3.5, so it's not coming out of the fabs that I was referencing earlier. We have a group that's been working on silicon photonics for many years, and they hold critical acclaim globally in some of the areas where they've been able to, and they've patented a bunch of this tech for the ability to go into the sub-wavelength realm to optimize signal coupling. So you can go into a fiber or out of a fiber or perpendicular from a surface with incredible efficiencies. Typically, and typical lensing and beam collimating strategies for getting in and out of fibers has always been an Achilles heel to the network and to components. But it turns out that if you get down into the sub-wavelength world, you can actually route really tight bends and emit from edges with surprising efficiencies. And so what we're able to do is take that technology that we have worked on and patented and moved it actually further out, not just into the coupling world and decoupling world, but into optical antennas. And so in the optical antenna space, you can then make an array, and you can steer that array without being electromechanical. And so because of the downside of this approach for lots of current optical phase array clients out there is how wide can you scan and how much efficiency power are you giving up by going with this approach. And the tech that we bring into this equation should be extremely sought after for those reasons. Now, again, this is low TRL, and we are not optical phase array or application level LiDAR product developers. And so for these lower type TRL applications and technologies that we're speaking about today, we would really be looking for a partner who is already in the optical phase array game. Someone that understands the things and the controls and how to manipulate and have the subsystems that they're already working with and are interested in improving the performance of what they're already working with. Okay. And my last section of technology for today, I'll correct Chris a little bit when he opened up and he mentioned the sensors. He spoke, unfortunately, he mentioned silicon sensors, and the answer is no, we are not silicon. Silicon sensors do dominate, obviously, low-cost markets out there. And so the backup cameras on your cars and in your phone, they're all silicon-based, and they have different lenses on them. But they all have, the strength is they're cheap. The downside is they are not multispectral, and they actually don't even work as well as your eyeballs do at the end of the day. Varying lighting conditions, washout, water peak, fog. There's a lot of things that that inhibit the performance of a LiDAR system based on current silicon sensors. So coming from a different area of research, but typically in the in-gas world and at the 1550 range, we spent a lot of time and effort developing, at the time, what was military grade night vision type sensors. And in doing so, over the years, we've come up with and realized, and we have intellectual property, that reduces the complexity of some of that while maintaining the performance. And as we reduce the complexities, we are also reducing the costs of these. Now, nothing can compete in the sensor world on cost alone against an 18-inch silicon wafer. We get that. But a 1550 based laser scanning system paired up with a large area planar focal array at 1550 as well brings a level of performance that can see in the dark, it can see in through fog, it can see in the rain. It sees everything that the human eye cannot see. Obviously, the catch here, oh, and also being at 1550, you can run everything at nominal power. You don't need to worry about the eye safety to the same levels that that the other competitive architectures have to deal with. That said, the cost point in these is still at a point where it may not be appropriate for an automotive LiDAR system, but boy, if you're building drones or if you're building niche market applications, the benefits of having a customized manufacturable shortwave LiDAR based sensor is a game changer in terms of the performance at the application level. And so we have been making these for years, and we have them in various customers in various, mostly in the camera and security spaces. But there's no reason why it wouldn't be appropriate for certain parts of the LiDAR space market. And that brings me to the end. And I'm not sure what I missed or what needs correcting. This is where I would probably ask Chris to jump back in and make me honest for anything that I have misled or have misrepresented or missed.
No, you covered it nicely, Mike. I think, basically, I think this slide was just to indicate that there are a lot of different approaches to how you can work with us. As I talked about Explore IP, we do license a lot of IP for developing commercial products and so forth. But I would say that the focus on most of this would probably be more in the collaborative development space, at least at this stage. And maybe down the road, obviously that would lead to a kind of a license structure, and we've done lots of that kind of work over time. So I think the message we want to leave here at the end is that, we're not, as we said, we're not the Lidar experts per se. We think we have some interesting technology that could provide some real game-changing performance, let's say. But we're really looking to team up with industry in order to further develop some of these technologies, and hopefully those companies can eventually supply new products into the Lidar market space. And I guess the other comment we'll just make here, and then we'll open up for questions, is that you've got below the emails of myself and Patrick. I'm not sure if Patrick is on the line, but either one of us you can reach out to based on other aspects, other parts of NRC, if you like, the IP world, the collaborations, etc. But Patrick it will be the point person when it comes to potential research collaborations with AEP. And that's about what I had to say, Mike, unless there's something else you wanted to add here.
No, I think that sums it up very well. Thank you.
Thanks a lot, Michael. Thanks, Chris. It was super interesting. So everyone, if you have any questions for our two speakers today, please write them in the Q&A section. In the meantime, I do have some questions for you guys. First of all, I wondered, in fact, you talked about the fruitful collaboration you had with a partner in this project. You briefly touched on the culture of collaboration at NRC. Could you tell me more about your philosophy regarding collaborations with the private sector?
Right. So although we do have, well, let me explain a little bit more about I mentioned that we have two different fabs on site and we have different research groups. And depending on what a client needs, you may end up in different parts of the building working in different opportunities with the different groups. In the space where there's a path to commercialization and the CPFC comes into play in terms of building up and providing parts all the way through up to an NPI level production, we work at 3 and 4 inch, we're moving to 4 inch wafers in this space. That could represent millions of lasers a year for a client. Okay, so we work all the way from very small volume all the way up to very large volume, depending on where you fit and what you're looking for, and obviously where our expertise lies. We cannot compete in terms of cost against a product that's already available on the market and coming from the Far East. But if you are in the product development game, it's a very interesting place, and we can support you all the way through that NPI type level. Now, specifically into your question about collaboration, it really depends on what the client needs are and how far along that continuum they want to come with us. So in some cases, if we're working on, well, in all cases, we sit down and we look at background IP from both organizations. And we draw boxes around, this is ours, and we will bring it to the table and we can license it to you. Or we can develop something together, and then we can talk about royalties or royalty sharing. We also have clients that want to just license from us and they want to go somewhere else with what has been developed together, or something that's ours that they need to take to another foundry themselves. So we really have a real flexibility that is client specific, and we're open. We're very open. The only thing that we really need to protect is the know-how on the process side of the equation. We've built that expertise, and we don't want to be locked out of sharing it with others down the road in terms of how we do things. But the application layer and what you're doing with it for your industry and your product, that's you. And we are very good at drawing boxes around that and never infringing. We are only as good as our client's success. We don't sell parts on our own. So we cannot ever step on the toes of our clients or compete with our clients. Does that help, or did I just confuse the equation?
I don't know, it was perfect. It was very clear. So thanks a lot for that answer. I'm sure the audience also loved it. Also, I wanted to talk to you about what you think the next biggest challenge that NRC wish to tackle in the LiDAR sector. What would you say, like in the next 5 years, where do you want to go in the LiDAR sector?
It's going to be super interesting. I'll let Chris canoodle on this while I just talk. What we've seen is it really is the Wild West out there. There are so many different competing architectures and approaches, and even fundamental device level approaches to solving how do you see the world three-dimensionally. And I think what we bring to the table, I spoke that we're a 3-5 semiconductor fab. So that means we work a lot in indium phosphide and InGaAs and GaAs, obviously, which are typical sensing and lasing materials. But because we have that ATF group in the exploratory fab, we work with exotic materials too. We get up into the antimonides and in all sorts of space and large molecule sensing type material sets and structures. So as the industry consolidates technology and architectures, and the winners of the right cost performance game play out in the next couple of years, I think it's going to get very interesting on the edges. Where do the specific specialty applications and niche markets, what do they need next? And so we get we have a lot of exploration interest coming out of, and I can't use some of these names, but space exploration type environments, or oil and gas looking for how do I sense if there are leaks in a pipeline from 5 kilometers up across a network of millions of kilometers of pipes. Well, it turns out if you have a laser that is emitting at specific frequencies out of exotic materials with tuned sensors, you can do that. And so I think that really for us, and where we come into play, it's always pushing the boundaries on, it may be a far out there niche market today, but as you prove the technology and you start scaling up, it lends itself to much, much bigger opportunities. And in fact, our client that I was referring to earlier that is seeing such incredible performance, and they're really making waves in the automotive space, they embarked on this to go after a niche market in aerospace originally, because they said, we are so good at this, we could make a laser that could do that. And I won't speak to that application, but they did it. And then what they realized was, well, then we could actually take that technology and look at, budding new industries that are coming online and needing this type of application. So for me, that's where we go as an organization, helping de-risk what are the next edges of, could you do that with this type of scenario? Chris?
Nice.
Yeah, and I think one thing I would add to that, Mike, is that, you know, I'm a big believer philosophically that you've got to let people that are playing in the market help dictate the needs that they have, and then you got to respond to those needs. And I think that's really, you know, as Mike's saying, there's going to be a lot of technologies falling by the wayside in the LiDAR space over the next little while. It's not always easy to pick the winners in those kind of scenarios, but I think if we have these kind of great collaborations with Canadian companies and so forth in this space that are really attuned to what's going on in the market and what the specific needs of customers are, especially when it comes to these kind of niche applications, that's really going to help us kind of, pivot toward the kind of technology, et cetera, that will be responsive to those needs in the marketplace. So I think it's key. That's a key part as well.
I'd like to bring up one other thing that probably was not clear. We don't compete and we don't make parts in industry, but we have amazing partners who do. And so for scenarios, and I mean, I literally have referenced, a success in the Lidar space and one of our great clients. If developing a specific sensor or developing a specific laser is not your business model, you are more of an integrator, we're still the right people to come talk to, because we will introduce you to those that are. And obviously we'll start with those that we know and we trust and those that we've worked with, and we will plug you in. And then quite often there's an amazing discussion that happens being a three-way party, which is we're the materials guys and we bring in the component developer team that is an external company to help work with further up the food chain, the integrators. So please don't feel that you need to be a laser component designer to give us a call. We certainly will introduce you or bring you into a conversation with those that can.
Thanks. Quickly, we have a question from Daniel Quentin that wants to know if you could share some performances like the peak power, CW power, modulation speed that could be expected from Silicon OPA.
I will have to get back to you on that.
That's fine.
Very specific technical question. And you're not talking to the actual researchers during this call, right? But we'd be happy to find out the answer to that.
All right. Anyways, we have your coordinates now. And I switch back to French since we're going back to the end of our allowed time. But merci à tous d'avoir participé à ce webinaire d'Optonique. Sachez que la présentation au complet va être disponible sur notre chaîne YouTube au cours des prochains jours, prochaines semaines. Donc, si vous désirez la visionner à nouveau, la partager à vos collègues ou à vos contacts pour qu'il y ait le plus de visionnement possible, ne vous gênez pas. Je vous rappelle aussi que ceux qui parmi l'audience pourraient être intéressés à rejoindre Optonique en tant que membre, c'est possible de le faire. Donc, tout simplement aller sur notre site web et dans l'onglet « Devenir membre ». Et sur ce, je veux remercier encore une fois Chris et Michael du CNRC de nous avoir fait cette super présentation. Donc, j'espère vous revoir bientôt, vous ainsi que l'auditoire, pour nos prochains webinaires. Donc, sur ce, ça a été mon plaisir de vous avoir et je vous dis à la prochaine. So, thanks, guys.
Merci beaucoup.
Salut.
Merci, au revoir tout le monde.
Au revoir.
Thank you, Chris. Thank you, Mike.
Absolutely.